you'll notice this section is techniques of integration. Forget you own the you have the calculators because you're not allowed to use them. This is all totally and completely by hand.
Awesome.
Okay, you will be eating some paper.
We will be eating paper and gross. Yes,
Today's not too bad.
I hear it's hard to digest. We better start now.
Okay, well, you start ahead.
We actually need to get a different kind of bacteria in our stomachs to digest that.
Okay, well.
We need a rumen too.
It was a figure of speech, all right? We are back to, all right, right now, basically, all you guys know for integration is you know how to do the power rule and you know how to use substitutes. There are tons of functions that will not integrate by those two methods. And even with the methods I'm going to give you now, we're nowhere close to knowing all the ways there are to integrate. Going backwards is considerably more difficult. But these are some more methods that do a lot of functions for you. Okay. Integration by parts is finally reversing one of the derivative rules that you learned before. Use substitution was the opposite of which, it was the opposite of chain rule, yeah. So, what have we not been able to go backwards on? Quotient rule is coming. That's where partial fractions is going to come into play later on. This is the integration by parts. We're reversing the product rule. So today's goal is how do I undo the product rule, essentially. Okay. To do that, or let me give you a little hint here of what it is you're trying to do. If you try to integrate that particular function, you can't use substitute it because the derivative of one of them is not going to cancel out the other one in any way, shape, or form. So we're stuck. We can't deal with it. Integration by parts is going to deal with that for us. And so I have to actually take you back a moment here. I don't want the integration sign on that. I got to develop the formula for doing this. Once you know the formula, it's not too bad. No, let's not freeze. So, back to the basics. If I said do the derivative of two things multiplied, what was the product rule? There we go. First, the second. The first times the derivative of the second, plus second times the derivative of the first. What I'm trying to do here, when we do integration by parts, what you're going to do is it's usually going to be two things that are being multiplied, like this one in the corner here. One of them is a function, one of them is going to be considered the derivative of a function. In this case, these are two easy functions that can be either way, but assume for the moment that if that was the function and e to the x was the derivative of some function, I'm trying to figure out how to integrate that. So I'm going to actually put on here integration signs. Now, on the other side, it is legal for me to say since there's an addition sign, I can do each of those separately. Okay, which one is the one we're out to find? If over here, if I said I wanted a function times its derivative, yeah, I'm out to solve for that one. So, okay, if this whole thing, f times g, this first part, if that whole thing is a derivative, what's it going to happen when I integrate it? Is it just going to go back to normal and be f times g? So yeah, so that one just becomes f times g. Okay. This one, the first one, is the one we're trying to find, so we're hanging on to it. That's the one we're trying to solve for. Okay, so then it's the other one. It's got part of it's a derivative, part of it isn't. So I'm stuck with it. But how do I get the one I need by itself? I got to subtract the other one over. So yeah, I'm going to end up with the one I'm looking for, f times the derivative of g. And I'm going to end up with f times g minus the integration of g times f prime. Okay, in symbols, we solved for it. We found what we wanted. We found the one we wanted, but that's not particularly helpful. So mathematicians, because when we use substituted, we use u's. And we know that when we do the derivatives, we get du's. We're more used to that notation. They translated this into u's and v's. So f is going to be u, and g is going to be v in the cabinet. Okay, so now, you have to translate the rest of this. G was which letter? V. Okay. This is the derivative of f. Yeah, so the derivative of u, or we're going to call it du. Okay. And then over here then, f was really u times dv. Okay, that's the formula you're going to work with. Okay. That is integration of parts. What you need to have in your head is u times v minus the integration of v du. And trust me, by the time we do this, you're going to have that rule down. I know, I agree. I've always thought that was kind of a crummy.
So should we try integration by parts when the u substitution won't work? Or what?
I don't know that I want to be there yet. You should try integration by parts when what has to be the situation?
The derivatives won't cancel.
Yes.
And two things are multiplied.
Yeah, you got two different functions being multiplied, two unrelated functions being multiplied, if you want to put it that way. We could pause while you're writing. Now we'll turn. Okay. So, in this case, how do you spot A that you're even doing integration by parts? Right now you would ask yourself, well, could I u substitute this? No, because if I u substitute for one of them, when I do the derivative, it's not going to cancel the other one.
Are you gonna have
Yeah, you can have some that you can use.
Yeah, are you gonna have some that we can?
On the test, it's going to be all the different methods we're learning in this chapter mixed up,
Okay.
and you're going to have to decide which
But on
method
the
it is.
final, you'll mix it up once.
Yeah, on the final, there will be some normal u substitutions. Trust me, you will be able to spot them. This will not be a problem.
You won't be able to.
All right, so what you are starting with is you have to realize that you're starting, the two things we have in this particular integration have to be u and dv. So what you're going to do is you're going to start out with, you have to set something equal to u and something equal to dv. And you have to realize, whatever you do to set for u, you're going to do the derivative of it, so we get du. Whatever you set for dv, you got to find v, so you have to integrate it. So you need to ask yourself, what do I want to do the derivative of, and what do I want to integrate?
Integrate secant squared and do the derivative of x.
And why did you say integrate secant squared?
In terms of the tangent.
Because we know how to do integrating secant squared. We know it's tangent. We know that has a nice integration. And yes, okay, on most problems, not all, but on most problems, you want, if you have just single x's, on most problems you want u to be x or x squared, because it's an easy derivative as the power gets smaller as you do it. There is one or two where you want it the other way, but most of the time that works.
But it's possible to not do it the other way.
Okay, you will know when you try this, if you set this up wrong, once you fill in the rest of the formula and you try to work it, you'll go, I can't do this. I must have set this up backwards. There's usually a big hint if you're set up wrong. It's like, I can't go anywhere.
That's a good point. What if you can't normally do it?
Yeah, what if you can't do it to start out?
You've all proved that you can do it.
Not yet. We haven't done this.
Okay. You've proved you can do integration.
We had calculators then.
Okay. So, now you're looking at it, you have to figure out, I need u to become du, so what's the derivative of x? Technically 1, but yeah, we're just going to go with dx. And then anything, whatever you set for dv, you have to figure out what v is by integrating it. So what's the integration of secant squared? It's tangent.
Plus b.
Okay, technically the plus c will go on the end of this whole thing later. You don't want that plus c in the middle of your problem.
Well, alrighty then.
Okay, so now you're going to apply the rule. It says, once you have figured out those four parts, hint, this is the way it's called integration by parts, because you figure out these four different parts, you now apply the rule, which says take u times v, which I always remember I multiply diagonally. So I'm going to have x times tangent of x minus the integration of v times du, or in other words, the two things on the bottom row. tangent of x and dx. Okay. So this first part, you don't have to integrate it. It's done. X tangent x is just sitting there. All we have to do is remember, how do you integrate a plain old ordinary tangent?
U substitution.
Yeah, but what if you use a tangent? This is a... Because if you use substitute tangent, you'll get derivative secant squared. That's not going to help.
1 over tan.
No. Right idea, wrong identity.
Cosine over, or sine over cosine?
Yeah. So, this is, we did it back in February. Yeah, tangent, you have to integrate tangent, you have to change it into sine over cosine. And then, okay, how'd that help me?
But you can change the tangent to it. You can use substitute a cosine.
I can
and a
use
derivative
substitute
will
for
change.
one of them. Which one would I want to use substitute for?
The sine.
If I use substitute the sine,
You do the derivative, you get cosine.
but the cosine will be...
Yeah, you do the cosine, you do the cosine, because you move it to
Yeah.
the bottom.
Yeah. This isn't going to come out right, so things will cross. So yes, you need it. Plus, you can't integrate a cosine on the bottom, so you want to get rid of that. So the derivative of cosine is negative sine. So the front just gets to sit here and go along for the ride. We're going to have sine of x. We got a u on the bottom now.
Or your negative,
Oh, these
negative
U's and
positive.
U's are gonna mess me up.
Yeah, I know. That's I wish you're using u's twice. That's
Or
confusing.
your negative out and negative positive.
Okay, because that's going to be du over negative sine of x.
Yeah. I like that.
And I would agree with you, but... So my sine of x's cancel. Alex wants to pull the negative out front. Are you guys buying this? Yeah, because they'll say that will become then a plus, which is fine. That's a good thing to do. Okay, so I'll have x tangent x. What's left? I'm going to write it out so you see it. You just have a 1 over u left. What's the integration of 1 over u? That's natural log.
Of the absolute value.
Very good, of the absolute value. Now, I think you can splash your plus t on the end of this whole mess.
That's it.
I have one tiny thing I need to do.
Put your little u back in.
I can't have u. I have to have all my answer in x's, so I have to go.
You got to put the cosine of x in there.
Yes, so it's actually the natural log of the absolute value of
Someone's
cosine of
gonna
x.
put in an x instead of just the cosine of x. Because the u up there, it says x.
I know. You're using the same variable twice. Believe me, I know. But you're supposed to be sophisticated enough mathematicians at this point to keep it straight. Which u is which?
You overestimate my abilities.
Obviously, the one that you use substitution with, you use that.
Okay. And ta-da! You have successfully completed your first integration by parts.
Yeah, the front just kind of chills. It's always like that.